Hi everybody. So I've got two problems from section 5.5 that I want to do. One was requested and the other one I'm just doing because I think you need to see it. So question 59 asks, how do you determine what the real roots potentially could be? And there's this little caveat in there, and that caveat is if it's a rational root, it's either going to be a factor of the lead coefficient or a factor of the constant, or if you take the factors of the constant and put it over the factors of the lead term or lead coefficient, and you generate any new values out of that. So the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. The factors of 1 are plus or minus 1, and I'm going to put this over the 2, so I get plus or minus a half. Put this over the 3, it's plus or minus 1/3. Put this over the 6, plus or minus 1/6. And here's the interesting thing. I actually thought I should, try and see if any of these actually work out, and I hit a dead end on all of them. And then I decided to graph it on the graphing calculator. So I went to my y equals and I typed this in. And the graph that I got, now mind you, I'm using an 89, so it looks a little different than yours. But I went to try and find the 0. So after I graphed it, I did second trace, and then I got this 0. Well, that's an irrational number. And so this root is irrational. Now I'm going to do second trace, well, you guys would hit second trace. I just hit F3, I believe. Nope, F5. There we go. And you'll see your screen that looks like that if you hit second trace. And I'm going to go to 0, and I'm going to hit, whoops, knock it off my table. I'm going to hit enter on 0, and I'm going to get the cursor. And see, mine uses lower bound, which just means left bound. So I'm going to get it on this side of where it's crossing. I'll hit enter. You see there's that little triangular shape. And then I'm going to move that cursor over to the right-hand side of where it crosses. And I'm going to hit enter. And it's telling me, and this is scientific notation, there's a float value issue, but negative 1.6984. That's irrational as well. And so we've got irrational roots going on. And so that's why that doesn't work. Even though these are part of the real number system, they are irrational roots. Okay, so just be forewarned on that. Sometimes you can be working on those synthetic division problems and they don't necessarily pan out. Also, and let me back up, 59 doesn't ask for that. All it's asking for are the potential roots and potential rational roots. Now number 40 says, let's find all of the roots, both real and non-real. And your function starts off being x cubed plus x squared plus x plus 1, and we set it equal to 0. Well, our factors of the lead coefficient are plus or minus 1, same thing as the constant. So I took negative 1 as my root, and I have my 4 ones, the 1, the 1, the 1, and the 1. I brought the 1 down. Negative 1 times 1 is negative 1. And I add those, I get 0. Negative 1 times 0 is 0. Bring the 1 down. I have negative 1 times 1. And this is an indication that this is a root. Now, what's remaining is a reduced equation. So this was an x cubed, so this is now an x squared. It knocks one of the roots down, or one of the powers down. Now, that's x squared plus 0x plus 1, so I could just write it as x squared plus 1. You could, at this point in time, use the quadratic, but because there's no middle term, I can just take it over and I'll get x squared equals negative 1, and then that's x is equal to plus or minus I, because I'll apply the square root on both sides. And if you're going to get irrational numbers as your roots, this is where it happens, okay? Not irrational, I apologize. Complex numbers as potential roots or as your roots, this is where it happens, okay? So you get it when you're down to the x squared. Then that's when you use your reduced equation and you can use the quadratic. Okay, I hope that helps.